All right. So, hi everyone. How are you guys doing? So, first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for ITJ. The topic that we are discussing right now is fluid mechanics. This is lecture number 3 of fluid mechanics, and today we'll be talking about mostly applications of Archimedes principle. Okay. So, hello, Thota Nandu, and hi Rajesh. How are you guys doing? All right. So before we get started with today's lecture, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE exam, both mains and advanced. As a student, I myself was All India rank 447 and All India rank of 192 in the two stages of the IIT JEE exams that I took. Now, I also qualified NTSC Stage 2 as a student, and I was in the top 1% in the NSCP examinations as well. Now, in this almost 8 years of experience that have been in the offline setups, now there I was able to produce a lot of course, many students to top ranks in the ITJ examinations, and now I hope to continue doing that here with you guys online. So, as I said last year, I also had to adapt and move to this online platform, which a lot of students were forced to do. So, how can you guys make sure that you guys are not suffering because of the lockdown and your studies are going ahead completely smoothly? So, one great way of doing that is by getting yourselves the Unacademy subscription. Now, when you get the subscription, you will have benefits like live classes where you get to interact with your educators on a regular basis. Then you also have live polls and leaderboards, and of course, you have test series and analysis sessions. And the biggest of all benefits that you get with Unacademy Plus courses is the live doubt clearing session. So, on all Unacademy Plus courses, every fourth session is supposed to be compulsorily a live doubt clearing session. So, an entire session dedicated to your doubts, be it related to your studies, be it related to your problem solving, be it related to your concepts, anything that you feel like. So that feature ensures that your doubts never pile up, okay, and your studies are going ahead smoothly. So hello Chandra, how are you? And hi Aftab. So hello to you guys as well. All right. Now, on top of all these benefits, the another great opportunity that this subscription gives you is the chance to study from the topmost educators from all across India on a single platform. So, I think that's a huge benefit, and every student must try and benefit from this. Now, how do you avail these benefits? So the first step of availing these benefits involves you to install the Unacademy app. Now, the moment you install the Unacademy app, you already unlock yourself a lot of features which are absolutely free. So there are free courses that are going on the Unacademy Plus app. Okay, and then of course you have something called special classes. So these special classes are lectures which are completely free for everyone to attend. So anybody who has installed the Unacademy app can simply join these special classes. So I personally take at least three special classes every week. So like that, a lot of educators also take these classes. So you can attend these classes just by installing the Unacademy app. You don't even have to buy the subscription. And of course, then you have quizzes like the ones that we keep having every Tuesday. So these benefits you will get completely free of cost just after installing the Unacademy app. And to unlock these features, you can use my code RD Live. So just give it a try. Download this app, try out these free features, and if you like them, then you can go ahead and get yourselves the Plus subscription. And to do that, these are the steps that you need to follow. Okay. So first, you will need to go to the plus section of the app. Then you will need to select your goal as IITJ, and finally, just click on that get subscription button. That is how easy it is. Okay, now once you do that, you will be redirected to the payment page where you will realize you will have a box that will say, "Do you have a code?" So remember to fill this code RD Live there in that box. So this code will give you a 10% off on all your subscription fees. Okay, now you can also choose from two kinds of subscriptions, Plus and Iconic, the fees of which are as mentioned below. Also, when you click on Proceed to Pay, you will figure out that you have a lot of no-cost EMI options to make these payments, which will ensure that you don't feel the burden of this payment also. Okay. Now, most of you know what the Plus subscription is, and a lot of you don't know the Iconic subscription. Okay, so let me tell you a bit about the Iconic subscription and what that is going to be like. So the Iconic subscription is something that will take your IIT preparation to the next level by helping you with personal coaches. So from our team of experts, you will be allotted some personal coaches who will closely mentor you and guide you throughout your IIT journey. You will also be able to attend a lot of IIT workshops receive timely expert guidelines, get a study planner, which I think is very important, and a lot of students can use that, right? And of course, you have regular test analysis sessions. So with all these features and with close and personal mentoring, your studies will definitely go to the next level. Okay. Now, if for all those students who are in class 11th, who are coming to class 11th right now and are looking for a one-stop solution for all their preparation worries, then this is what you can do. You can go for one of these combo subscriptions. So now Unacademy is also offering combo subscriptions, which include your subscriptions for IIT JEE preparation and your 11th, 12th CBSE preparation. Okay. So the first combo that Unacademy offers is the iconic subscription for IIT JEE and the plus subscription for 11th and 12th, and the subscription starts at around 4600 a month. Then you can go for a combo which offers all three iconic subscriptions. This combo starts at roughly around 5500 a month. Finally, you can go for a plus subscription combo for all these three. Then this subscription starts at 3000 a month. And finally, you have a combo where you get the plus subscription for ITJ and iconic for class 11th and 12th. So this subscription starts at 3900 a month. Depending on what kind of need you feel, you can go for a combo subscription also, and this combo subscription will ensure that for the next 2 years you don't have to worry about your studies. Okay, be it about your boards, be it about your 11th, 12th school examinations, be it about your JEE mains and advanced. Okay. Next, okay, the next Unacademy combat is also going to happen on the 17th of January. So make sure you're competing in that live, and if you do well, you can win yourself a lot of cool rewards and prizes. Okay, so you can enroll now using the code RD Live. Make sure you're taking part in this, doing well, and winning yourself some really cool prizes. Right now, those of you who are following us on the JEE English channel of YouTube can also connect with us on the Telegram app using this link. So this will make sure that you're receiving all timely notifications of all the lectures and sessions happening on this channel. Okay, so that you're not missing out on any of this amazing free quality content. Okay. All right. So finally, let's get started with today's topic. Okay. So today, as I said, we will be talking about fluid mechanics, and today we'll be focusing on applications of Archimedes principle. Okay. So let's start with a quick question, which should help you get your discussion from the past class revised. Okay, in the previous class we talked about Archimedes principle, where we said that any body that is submerged will feel a net upward force due to the surrounding liquid, and that force is called the buoyant force, and that will be equal to the weight of the liquid displaced. I also told you the logic of that, and I showed you the proof of that. It was an argumentative proof, but I hope that got you convinced. All right, so this is a question that relates to that. So you've been told a block of mass 1 kg and density 0.8 gram per centimeter cube is held stationary with the help of a string as shown in the figure. Now the tank is accelerated towards upwards. Okay, so the tank is being accelerated upwards with an acceleration of 1 meter per second square. You have to find the tension in the string, and if the tension is current, what is the acceleration of the block? Okay, try and figure this out. Okay, hurry up. This is a very standard situation. A very good question on the application of Archimedes principle. You should be able to figure this out. Let's see how many of you can. All right, who are trying this then? Let me know if you're trying this. Okay. Okay, so try this from up. What do you think would be the answer? Yeah. See. Okay, AP. All right, let's see. Okay, you can consider G to be a 10. . So you can take the value of G to be 10. What do you think would be the answer? Okay, so try this. So does anybody have an answer then? Okay, people, hurry up, give it a try. Let's see how many of you can figure this out. Okay, Motilal is trying. All right, Motilal. Let's see. Okay. So AP says 2.2 newtons. Okay, let's see if that is correct or not. Tanya also says 2.2 newton. All right. Okay, let's see. Hmm. Okay. Hmm. How about Motilal? So let's wait for Motilal also to give his answer, and then maybe we can discuss the solution. Right? Okay. So obviously, first of all, what you need to do is you would want to make the video of this, right? So let's try that. Imagine this is your block. What are the forces that it will experience? The forces that it will experience. Again, let's try and solve everything from the reference frame of the container. Okay, so I can say from the reference frame of the container. What are the forces that you will see? Okay, Motilal also agrees with 2.2 Newton. All right, let's see if that is correct. So you will have a downward force mg effective, correct? Then you will have an upward buoyant force, and then of course you will have tension. So these are the three forces that you will see in the reference frame of the container. Okay, why are we moving into the reference frame of the container? Because I need my fluid to be stationary. Okay, so that I can figure out what kind of buoyant force is acting. Okay, so what I'll realize is that in this reference frame I should see uh, my block to be stationary. So I can say since in this reference frame, the block is stationary, right? So what do I expect? I expect this net sum of all the forces to be zero, correct? So can I say buoyant force should be equal to tension plus G effective, or I can also say T would be equal to buoyant force S M G effective, correct? Now what is the buoyant force? Buoyant force would be the weight of the liquid displaced. Now weight of the liquid displaced is volume of the liquid displaced, so which is the volume times rho of the liquid times G effective minus mg effective, correct? Now what is the volume? Now I know the volume of this would be, if m is the mass, m over rho of the solid, that is v, correct? And that would be the weight volume of the liquid space also. So can I finally say that T should be equal to m over rho of solid into rho of liquid times G effective, yes, mg effective. Now since the container was going up with an acceleration of 1 meter per second square, so what is the value of G effective? What I'll realize is G effective obviously is 11. Okay. in the reference frame of the container, the effective value of G is, so Amod says 5 Newton. Let's see. So now all I need to do is substitute all these values. M is 1, okay. Now rho of liquid, let's say I'll use the SI units, okay. So SI units, the density of water is 1000 over the density of the solid would be 800 minus 1 times G effective, which is 11. So what do you get from here is 11 by 4, okay. This is 5 by 4, correct? So 1 minus 5 by 4 is 1 by 4. So 11 by 4 is the answer. So 11 by 4 would be 2.75 actually. So 2.75 Newton is the correct answer, okay. It's not 2.2, it's not 5 Newton. The correct answer is 2.75 Newton. Okay, I hope everybody agrees with this. Just go through this. Okay, and let me know. Okay, agreed. Now let's come to the second part of the problem. Second part of the problem asks, if the string is now cut, find out the acceleration of the block and with respect to ground. Let's say with respect to ground has been, because by default that is what we say. Okay, if nothing has been mentioned, then I'll assume that I'm going to ask the acceleration of the block with respect to the ground. Okay, so how do I find that? Let's add one page solution. So imagine that the string is cut. So if the string is cut, what I immediately know is that in the reference frame of the container, so it feels two forces now, mg and the buoyant force. Okay, we already know what this net force is. So I can say in the reference frame of the container, summation F is B minus mg effective, which we already calculated, just 2.75 Newton. Right. So what I get is the acceleration of the block in this reference frame. Acceleration of block with respect to container, 2.75 meter per second square upwards. Right. Now that I know the acceleration of the container with respect to the container, of the block with respect to the container, I can also find out the acceleration of the block with respect to ground. Therefore, the acceleration of the block with respect to ground would be 2.75 plus the acceleration of the container plus 1. So the answer for the second part is 3.75 meter per second square upwards. Okay, so that is the answer for the second part. I hope everybody followed this. So if you have any doubt regarding this, how we are calculating the acceleration, you can let me know. Okay, and if everybody is convinced with this, then also you can let me know and I'll move ahead. Okay, so is that clear? Is that clear? How we got the answer? Okay. Okay, why are we doing this in the reference frame of the container? Because you know that the buoyant force and everything that we are calculating is for fluid statics. Your fluid should be stationary, okay? So it is stationary in the reference frame of the container. So the buoyant force that you are finding has to be in the reference frame of the container only, okay? Because you know the pressure also varies not only because of the gravity, because of this acceleration also there will be additional variation in pressure. So the buoyant force would be the weight of the liquid in the reference frame of the container. Okay, that is why it is important to calculate this in the reference frame of the container. Okay, I hope you are clear about that. Okay, the buoyant force will not be rho g v, where g is the acceleration due to gravity. No, that is not the buoyant force is going to be. The buoyant force, in fact, is going to be Rho VG effective. Okay, so be clear about that. That is very, very important. Next, we'll talk about something called the law of flotation. So this law suggests that if you consider a body with a density d naught and it is released in a liquid of density dl, now there are three possibilities, right? If d naught is greater than dl, then what you realize is that its mg would be greater than the buoyant force, and such an object will obviously sink. Okay, why? As the mg of the body is greater than the buoyant force. Now, if d naught is less than the density of the liquid, then what happens is that such an object will float partially submerged. Okay, why? Because the buoyant force is more. So the buoyant force, if you submerged it, buoyant force would have pushed it up, and the moment it comes out, the buoyant force would have reduced, and eventually it would have found a position where the reduced buoyant force would have been able to be equal to the weight of the object, and that is where it would have floated. Okay, and of course, finally, if d equals dl, then the object will float just completely submerged. Okay? Now, please note that whenever an object floats in a liquid partially or completely submerged, the buoyant force on the body is always equal to the weight of the body. That is what you call the law of flotation. For any floating body, if the body is floating, what I can say is that the net force on it must be zero. Okay. And if the net force on it is zero, so there are two forces that I know are acting on it, the force of gravity and the buoyant force. So both of them must be able to balance each other out. That is the only condition under which this will float, right? Okay, so that is what you have. Now, let's talk about some interesting situations. Okay, so this is a practice problem that I have for you, and a similar problem I think was asked in mains. Okay, so if I remember correctly, this is a mains PYQ, mains previous year question. Okay, so let's talk about this. You have been told a boy is sitting on in a boat floating in a swimming pool as shown in the figure. Now, there are some heavy iron balls in the boat, and the boy throws all the balls into the pool. What happens to the values of capital H and small h after his action? Okay, capital H being the height of the water level in the pool, and small h is the height, which is the height of the boat submerged. Okay. What will happen to both these values? Think about this and try and answer. Okay. So again, a theoretical question. A lot of questions like this are asked in your JEE Mains. So just think about it a bit, and this should be easy. Okay. Very very standard situation. Very frequently asked in your exams. Okay. So try and give the answer to this. Okay. Let's see. जल्दी ट्राई करो भाई. Let's see how many of you are trying. Okay, AP says simple. All right. It's D. Okay. AP thinks it's D. The Sai Teja says, sir, confusing with thumbnail for the fourth time. Okay, so I don't know what you're saying. Okay. Not sure I follow you, Sai Teja. This is J Fluid Mechanics, lecture number 3, discussion of class 11. So what is confusing about it? Okay, so two of you think it's D. Let's actually D is the correct answer. Yeah. Okay, so small h will get reduced. That should be obvious. Okay, if you throw all these balls out, if you're throwing all these balls out into the water, then small h obviously decreases. That should be very, very obvious. The thumbnail is showing all three teachers. Okay, well, right. I don't know. I don't know why that is. Okay, let me just check it out. Hmm. No, which thumbnail are you checking? The thumbnail for this class is showing a container, and it says Archimedes principle 2, and it just shows me. No, no, I think you saw some other thumbnail. No, I can see the thumbnail. It is fine. It is fine. Hmm. It does show fluid mechanics. Yeah, what are you saying? You go to the homepage of this channel, and you will see. No, no, no. I just saw it. I just checked it. It's fine. It's fine. Yeah, I don't know. I don't know. Maybe you saw some other thumbnail. All right. All right. Anyhow, discussing the answer of this. So I hope everybody should be convinced that H will decrease. Okay. Small h will decreases as for flotation. Weight of the water displaced, weight of the liquid displaced or water displaced must be equal to weight of the boat. Correct. Now, because you're throwing the balls out, so the weight of boat is decreasing. Since this is decreasing, so the other thing should also decrease. Hello, Chota Nandu, how are you? Oh, sorry, it is Thota Nandu. So since this is decreasing, so the weight of this will also decrease. So small h decreasing should be very easy to see. Okay. How about the capital H? How about the capital H? If the small h is decreasing, maybe capital H should increase, right? So let's talk about this. So let's consider that you have initially you had a volume V naught one here and V naught two here. Okay, before you threw the balls out. Okay, let's imagine that was the volume. Okay, now I can say inside you have inside the boat inside the boat you have masses of two things, the boats itself and the balls. Okay, so mass of boat. Okay, that's mass of iron balls, boat and the boat and person. This G should be equal to V naught 1 rho G. Agreed. Initially that is what V naught 1 would be. That is the volume of the water displaced. Now I can also say V naught 1 plus V naught 2 would be equal to area of cross section of the swimming pool times capital H. Okay, this will be the total volume. Next, which lesson are you starting? So after fluids, we will move to, I think, thermodynamics. Okay, we will start with thermodynamics after fluids. Okay. All right. I hope everybody can see that. Now, later on, what will happen is that you have thrown all this into the water. Thrown all this into the water. So what happens to the final volume? Finally, the volume of water. You have three volumes. Finally, you will realize the situation would be like this. Okay, maybe let me add a page. to show you what the final situation is going to be like. So finally, you would have had the boat, and then you would have had the container, the swimming pool, and some other height of the boat that would have been inside. Okay, so what I'll do is, if I look closely, I can have this volume first. Okay, let's call that volume V1. Okay, let's call this volume V1. Then you will have some volume of water. Let's call that V2, and you will also have some of these balls lying at the bottom. Right? You've thrown all these balls out, so all these balls would also be lying at the bottom. So volume of iron balls. So these are the three constituents that you'll have. Okay, you'll have some volume which is getting displaced by the boat. Then you'll have some volume of the water, and then you will have some volume that is being occupied by the iron balls themselves. So can I say if this height is h dash and the area of cross section is again h, then can I say that finally volume of iron balls plus V1 plus V2, that should be equal to A times H dash. Okay, agreed. Now let's talk about this. What will be the volume of the boat that is getting displaced? So volume of boat getting displaced, volume of iron balls is going to be mass of iron balls over density of iron balls. Correct? This is going to be the volume that is occupied by iron balls. Then the volume of the boat is going to be volume mass of the boat plus person. Okay, over density of the water. Correct. This is the volume that the boat will displace. So it will displace a volume of water which will have the same weight as this. Okay, the mass also should be same. This is the volume that V2 plus V2 would be equal to V2 naught, which is the earlier volume of water. So the volume of water will not change, of course. Okay, so this should be equal to AH dash. All right, I hope everybody agrees. Now what you need to do is, now let's just compare this to this. Okay, so this term is the same. I have this term different. I have this term different, and this term here. So let's just compare these two terms. So if I compare these two terms, let's see what I'm getting. So I can say what was V naught one? V naught one was equal to, if I use this equation. इस equation को देखो जरा. Let's just focus on this equation here. So if I remove the G, then what I'll get is V naught one. V naught one is, can I say V naught one is mass of boat plus person over row of water plus mass of the iron balls over row of water, right? And I wanted to compare this to, on the other hand, finally I have also finally I had mass of boat plus person over row of water plus mass of iron balls over row of iron balls. Correct? So if you compare these two, this is V1 plus V of iron ball, correct? So if you compare these two, what you will realize is that this term is the same. How about this term? You realize this is greater than this. So V1 plus V iron balls is actually less than V1 naught, V naught 1. Why is so? Because here you will realize the mass in the numerator is the same. In the numerator, you have the same mass, right? Okay, so highlighter doesn't work here, I guess. Okay, never. So the numerator is same. In the denominator, here you have density of iron. Here you have density of water. Density of iron obviously is more than the density of water. Okay, so I can say as rho of iron is greater than rho of water. So that is how I know that the final volume displaced of the water is less than this. Okay, now once I know this, I immediately know that therefore AH dash is less than AH, or I can say H dash is less than H. So H also decreases. So that is why this is the correct answer. Okay. I hope everybody followed the logic. Just try and follow the logic, okay? And if there is any confusion regarding this, you can let me know. Okay. All right. Now let's move on to the next one. Again, a very interesting typical situation, which is very likely to be asked in advance, even in mains for that matter. So here you've been told that a block of mass 1 kg and a density 0.1 gram per centimeter cube is held stationary with the help of a string as shown in the figure. Now the tank is accelerated towards right with an acceleration of 5 meter per second square. Then the direction in which the string turns is okay. So in which direction will the string turn? Towards right, towards left, it remains vertical, it becomes slack. So which of the following options is correct? So think about this, and let me give your answers. Okay. Hello Arjun, how are you? So what do you think about this problem? Let's try and answer this. This is a very simple theoretical problem. Okay. What do you think the answer is going to be? Which way will the string turn if you accelerate this vessel? Will it go to the right? Will it go to the left? Will it stay vertical? Or will it become slack? So think about this. Okay, so Tanya is trying. Great. Left. Okay. So Arjun thinks it will turn left. Hmm. How about others? How about others? So this is what Arjun says. Arjun says it turns left. Okay. So this is what ARJ says. Obviously A. Okay, AP says A. All right. ARJ is saying this and AP is saying this. Anybody else? Mahi also says it's B. Okay, Tanya is saying A. Okay. So we seem to have our community divided between A and B, right? So let's think about this. Let's think about this. Do not randomly guess. No, you've been studying this. Why? Why have you been studying this? Hmm. So think about this. Think about this. When the vessel is accelerated, what is the direction of G effective? So the vessel is accelerated like this. So you would have had a pseudo force in this direction and G here. So what you will realize is that the G effective would be acting in this direction. Agreed. In the reference frame of the container, G effective has this direction. Correct. Do you guys agree? Now, if this is the direction of G effective, now you will realize mg would act in this direction. Mg would act in this direction. How about the buoyant force? Buoyant force obviously starts acting in this direction. Okay. Because the buoyant force has to be the opposite of that, opposite of the weight of the liquid displaced, right? So since the buoyant force is higher, in this case, in this case, in the reference frame of the container, G effective and B have the directions as shown. Now, since buoyant force would be greater than mg effective, why? Density of liquid is greater than density of solid. So, which direction will win? So, obviously the block will try to move in that direction. That is the direction of the net force, right? So that is why the thing will actually go towards this direction, towards the right. So A is the right answer. So I don't know, most of you were answering B, but A is the right answer. AP is absolutely correct. Okay, so I think Tanya and AP were the only ones who gave A as the answer. Rest everybody was saying B. Okay, so A is the correct answer. Okay, ARJ. All right, I hope you followed the logic, and everybody who was saying B. I hope now you guys realize that the correct answer would be in fact A. Okay, this should make it clear. Okay, so interesting situation. Yeah, I know. So, but I hope now the logic is clear. Hmm. And now you should know how to calculate this. Okay. Now, next we will talk about another application of Archimedes principle. Again, most of our discussion for today is going to be focused on problems, and with the help of these problems, we will try to learn the applications or learn how we can use Archimedes principle to get all of these things. Okay, so here you've been told a metallic sphere floats in an immiscible mixture of water and a liquid of specific gravity 13.5, such that 4/5 of its volume is in water and 1/5 in of the volume is in the liquid. To find the density of the metal. Okay, what do you think the density of the metal is going to be if it is floating in two liquids? Okay, try and answer this. Hmm. So ARJ, you're a trendsetter. Even if you say something wrong, people follow. See? Hmm. So try this one and let's see if you can figure this out. Okay, AP immediately has an answer and he says C. Okay, how about others? Hmm. So ARJ, I think Arjun, a lot of people have faith in you, na? That's why they copied you. Sir, there is any drastic difference between chemical thermo and one in physics except Carnot in refrigerator. I'm almost done with one in chem. So asking, yes, yes, there are a lot of differences. There are a lot of differences there, Arjun. So you have enthalpy there, you have Gibbs free energy there, if I remember correctly. We don't discuss any of these. We don't discuss any of these in physics, right? He's not AP, he's AIR1. Okay, and I think there are some more parts that we don't discuss. We don't discuss the real gas equation in physics. No discussion on a real gas equation. We stay away from real gases. And then we also do not discuss irreversible processes. We only analyze perfectly reversible processes. So those are a few differences between the thermodynamics in physics and the thermodynamics that you discuss in chemistry. Okay, and when I teach you, I will tell you exactly why we do not do those things. Okay, because in chemistry, you're doing is not entirely correct. That is why we don't do it in physics. Physics, we like to do the correct things or not do it. But basics are of course the same. Basics are of course the same. Okay. All right. Now the correct answer for this, let's see, is I think if I remember correctly, is C. So AP, yes, soon to be AR1 is correct. Okay. Let's try and analyze this again. So what you have is you have a container having two immiscible liquids. Okay, so let's say for some part you have mercury, which is the liquid with density of 13.5. So here rho is 13.5, and then you have water. First, the density is 1. These are CGS units. Okay, okay. And now you've been told that you have placed a sphere inside it. A sphere is placed inside this such that when it floats, it has 1/5 of the volume inside mercury, and here is your floating sphere. This floating sphere has 1/5 of its volume inside mercury and 4/5 of its volume inside water, right? That is the situation that has been given to you. So this is the part submerged in water, and then you have a part submerged in mercury. Like this. What you have been told is that this part, if the total volume is V, then this part has a volume of V by 5, and this part has a volume of 4 by 5V, correct? Where V is the total volume of this sphere. Right. Now, with that information, let's go ahead and solve this. So, since it is floating, according to law of flotation, according to law of flotation, I can say that V into rho of solid or the sphere into G should be equal to the net buoyant force that it is experiencing. That will be the weight of the two liquids displaced. Okay, so that'll be 4V by 5 rho of water into G plus V by 5 into rho of this, which is 13.5 times the rho of water to G. Correct? So your G G and your V would have gotten cancelled, and density of the sphere turns out would have been 4 by 5 row of water plus by 5 in 0.5 row of, so that will have been 17.5 by 5 row of water. Row of water you should know is 1000, correct? So that will be 5 in 1000. This will be 3.7, 0.5. Yes, 3500 is the correct answer. Okay. So yes, absolutely right, AP. Okay, well done. So again, please go through the solution and let me know if you followed the logics. Okay. This is how we want to essentially use Archimedes principle to find different values. And this is a typical problem that is asked. That can be asked very easily in your mains and advanced both. You should know how to figure things out. Okay. All right. Now with that, let's just move on to the next problem. If there are no other doubts. Okay. The next question is like this. So this says a sphere of radius capital R and made up of material of relative density sigma has a concentric cavity of radius small r. Again, this is a very standard question. Okay, so I am trying to discuss the standard questions on this topic, which you need to at least know. If you know how to analyze these standard questions, then you will be able to solve a lot of questions related to this topic. Okay. So you've been told that material has a relative density of sigma and has a concentric cavity of radius r. If it just floats when placed in a tank full of water, then what will be the ratio of r over r? Okay, so try and answer this. See if you this one out. Okay, so I'll give you guys a couple of minutes to figure this one out. So knowing Archimedes principle and knowing the extent of its use, application, and how to use it are two different things, and that is why I think it's good that we are discussing these problems. Okay, so that you don't only know the Archimedes principle, you know how to use it. Okay, so try this and let's see. Okay, again a very common question which you will find at a lot of places also. Okay, so that's why I'm trying to take the common, slightly tricky problems. Okay, slightly tricky problems, of course. Uh, this would be somewhere around your mains level, not your advanced level, not your board level either. Okay, so I'm trying to take up some problems which are of mains level. Okay, and let's see if you can figure out how to analyze these. है ना, ये करना सीख जाओ, बाकी फिर कर लोगे आराम से. All right, let's see. So any answers for this? Any answers for this? So you do realize that the ratio should be less than, should be greater than 1, right? Should be greater than 1. The first one is greater than 1. The second one is less than 1. The third one is less than 1. Fourth one is greater than 1. So two options you can easily eliminate just by that. So logic says that I know r by r must be greater than 1, right? You cannot have a hole which has a radius greater than the radius of the sphere. Okay, agreed. I hope that you can immediately find logically. But r by r should be greater than 1. Now this is one option which is greater than 1. This is one option that is greater than 1. So you can immediately eliminate these two options. Both these options are less than 1, which would mean that the radius of the hole is bigger than the radius of the sphere, okay, which is not possible. Okay, so immediately you can shortlist down to two options, and then you can figure out what the correct answer is. So let's try and calculate. Let's try and figure out what answer would have been. Okay. So imagine you had this sphere, okay, having a radius capital R, and inside you had a cavity of radius small r. So this is what you would have had. Okay, this is what your thing would have looked like. The material. Okay, a sphere of radius capital R having a hole of radius small r in it. That is the question. Correct. Now you know for this to float, and this is floating completely submerged. That has been told to me. So if this is floating completely submerged, this is the situation. So now what I can say is from the law of flotation, I know one thing, that the weight of the floating object should be equal to the buoyant force. Weight, so I can say from the law of flotation. Can I say that the weight of this should be equal to the weight of the liquid displaced? So weight of this would be rho, sorry, sigma. Sigma was the relative density. Sigma into rho, that would be the absolute density. Sigma rho into 4 by 3 by r cube minus r cube, that would have been the volume. This should be equal to rho times 4 by 3 by capital R cube, because this is the volume of the liquid displaced to G. Great. All right. So what does that mean? That means let's get rid of these two first. Let's get rid of this also. And what I realize is that if I take this r cube here, so 1 minus r over r whole cube equal to 1 over sigma. Okay, so that gives me r over r whole cube would be 1 minus 1 over sigma. So that tells me that r over r equals sigma over sigma minus 1 to the power 1 by. So that is going to be our answer. Okay, which is option number A. So I already told you that we had already eliminated options B and C by common sense. Common sense would have said that option B and C should not be correct. So that left me with options A and D, and if I had to take a guess, I would have gone for any. Okay, so again, I hope everybody followed this. I hope you guys followed the logic of this and are convinced with how we got the answer to this. If there is any confusion, then you can let me know. Go through the solution one more time. Okay, just go through it and let me know. Okay. All right. Now, why don't we move on to the next problem? Another very tricky problem. And this, trust me, I have noticed at most of the places the answer is given wrong. I've seen solutions been given wrong. Okay. Student says, sir, how many days to start the next lesson? Okay, so let's say today is what? Today is Wednesday. Okay, so we will need another 5 sessions to 6 sessions. Okay, so let's say 3 weeks because we are having 2 sessions per week. Okay, and I need at least 4 sessions maybe minimum for completing fluids only. Okay, so at least 2 weeks, 2 to 3 weeks, you can say. Okay, Nandu, why don't you try this problem only? So if you're done with your fluids, why don't you try this? Let's see if you can figure this out. Trust me, this is one problem. This is one problem which I feel a lot of places have given the wrong answers also. A lot of places have given the wrong answers and the wrong solutions. Okay. So please try this one. This is a very, very good problem and a very, very simple application of Archimedes principle. IIT Advanced would love to ask you something like this. In fact, they have asked things like this. Okay, so this is a problem that they would love to ask. Think about this. And this says a sphere of radius capital R and relative density 4 is hanging with the help of a string such that it remains just inside water. The ratio of the force exerted by the liquid on the upper half and the lower half of the sphere is. So try this problem. This I think you should, all of you must try. The must try problem. Okay. Option two. Okay, Nandu. No, that is incorrect, unfortunately. Not correct. Okay, maybe you want to give it another try. As I said, this is a must-try problem. All of you should try and find the answer. Okay. Let's see. Let's give you one more chance. Okay. Okay, Sabrish. So why do you acquired Akash? Have you heard the news? Yes, of course I have. Yes, of course I have. Of course I did, Sabrish. I think I like that decision. I think that's a great move because moving forward, I think you would or every company would need a hybrid kind of a model for with your both options available for online as well as offline setups. Okay, so I think it's a move towards that Byju's is making. They want to acquire an offline setup also. Okay, so it does make sense. It does make sense. Okay, and Akash bring such a big brand name, and that'll give their model also a big boost. Hmm. Now Nandu says option 3. So sorry Nandu, option 3 is also incorrect. Interestingly enough, if you Google this question, there are some places that give option 3 as the answer. This is answer given on Google, I think. Google, if you do Google, then the first few options, the first few answers actually are like this. But that is wrong. And that was why I wanted to discuss this. So don't trust Google completely, okay? A lot of things that are there on Google are rubbish. Okay. A lot of things are wrong there. Okay, Chota Nandu. So I don't know if you tried this on your own or if you tried to Google this. Hmm. So that's one big issue with online thing, right? There is a lot of content available, and people get away with that because there is nobody to correct it. So now, are you ready to see the solution, the correct solution? That is, tell me, Mr. Nandu. I know. That is why I'm discussing that. No, इसीलिए तो मैं डिस्कस कर रहा हूँ इसे क्योंकि लोग आसानी से करेंगे नहीं बाकी लोग आसानी से करेंगे नहीं ऐसी प्रॉब्लम्स डिस्कस not too many people would discuss these confusing problems. Okay, so let's talk about this. So first of all, let's divide the sphere into two halves, the upper and the lower. Now think about this. Think about this. What happens? What happens if I want to calculate the force on the upper half due to the surrounding liquid? Here is some pressure, then some pressure, then some pressure increasing, pressure here, and similarly like that. Okay. So on the upper half, there is some pressure because of which there will be a downward force, correct? Again, I am only interested in calculating the magnitude of that. So how do you calculate the magnitude of that? Now for that, you will realize even if I cut off these lower half, so this is the trick. Even if I cut off the lower half, you should know that the force exerted by the surrounding liquid on the upper half will not change. Okay, so that's the trick for this question. I hope you're convinced about that. If the lower half is cut away, force by the surrounding liquid on the upper half will remain unchanged. Right? You guys agree to that? So when are you going to explain communication systems? Okay, communication systems would be the last topic of class 12, right? So class 12, we are currently discussing ray optics. So after ray optics, probably we will move on to modern physics. And then after modern physics, maybe we'll talk about communication. Okay, okay, Afrita. All right. Now, first, just let me know if you are convinced with that. See, the point is that you realize whether I keep the upper lower half or not, the pressure on all the points is going to be the same. Right? So think about all the points on the boundary, on this entire boundary. What you'll realize is that the pressure at all the points will be independent of whether the lower half is there or not. And the surface area obviously is also unchanged. So you realize the force exerted by the surrounding liquid on that upper hemisphere does not change even if I remove the lower half hemisphere. Correct? That should make sense. And you know Telugu? No, I don't know Telugu here. I only know Hindi and English. That's about it, Nandu. Okay, so no Telugu. All right. So first, I hope you should be convinced about this. Now, once you're convinced about that, now things are very easy to see. Now, all you will realize is that if I have this hemisphere now, on that hemisphere, the net force by the surrounding liquids is being exerted on two surfaces, correct? One here on this hemispherical surface, and again the second one is here on the circular surface, correct? The net buoyant force must be a result of the force on the liquid. Let's call this F1, and let's call this F on base. Okay, correct. Now, can I say net buoyant force for the situation shown? For the situation shown, I know net buoyant force must be equal to force on base, which is the upward force, and minus the force on the upper hemisphere. Okay, that will be a downward force. Okay, so that is what I should get. Now I already know what the buoyant force is going to be. Buoyant force is obviously going to be weight of liquid displaced. Right. Now, if I ignore the ATM atmospheric pressure, which has been told to me, then I know the pressure here. P here would be rho GR. Wait, the pressure here would be rho GR. Okay. So finally, what you will realize is what you will realize is that buoyant force, which is 2 by 3 by r cube rho, would be equal to F on base, which would be rho GR into pi r square minus F. That will give your F1 as 1 by 3 by r cube rho G. Right? That is the force experienced by the upper hemisphere. Agreed? I hope there is no doubt. Now what you will do is, okay, will do is, again, you could have also calculated this another way. Uh, I'll tell you. I'll tell you another way of calculating this. Okay, so for those of you who are not convinced with this, I will tell you another way of calculating this. Okay. So alternate way of calculating this is this. You consider this portion. Consider this portion. And consider this liquid. The liquid in this portion. You realize this, if you talk about this liquid, then how is this liquid getting balanced? How is the weight of this liquid getting balanced? It must be receiving some N from the sphere, correct? Some upward force it must be receiving from the sphere. And that should be balancing the mg of this liquid. So, if the sphere is pushing the water up by N, then the water would be pushing the sphere down by N, Newton's third law. Right. So can I say N would be equal to mg of that liquid, where m is the weight of this liquid. Now weight of this liquid would be, can I say the volume of this cylinder? You have a cylinder which has a height r and a radius r. So what is the volume of the cylinder? Pi r square h. Okay, so this is the volume of the cylinder minus the volume of the hemisphere. Correct? To g. So again you would have gotten pi r cube. Okay, I hope you guys are convinced now that I'm getting this same answer by two methods. Okay. Now for the lower half, what I'll do is I'll do something different now. For that, I will remove the upper half. Let's remove the upper hemisphere. If I remove the upper hemisphere, then I have two forces acting on this. One, which is the force on base, and other is the force on the surrounding liquids. Let's call that F2. Okay. Please see the timing of your class. I had a new to your class. Okay, so timing of my classes is every day at 4. What class are you in, Nandu? So for similarly, I can say for the lower half, we can remove the upper portion, upper hemisphere. So if I remove the upper hemisphere, then what happens is that I realize that F2 minus F on base should be equal to the buoyant force. So which will give me F2 would be equal to the buoyant force, which would be 2 by 3 pi r cube rho g plus the F on base. F on base again here the pressure you will realize is rho gr. So it will be rho gr into pi r square. Right. So what is it that you're getting? You're getting 5 by 3 pi r cube rho g. So you got F1, you got F2. Now you can simply find F1 and F2. Okay, you are in class 11. So for class 11 students, I take sessions on Mondays and Wednesdays at 4. 4 to 5:30. Those are my timings. Okay. All right. So I hope you guys followed this. I got my F2. I had my F1. So now F2 is to F1. How much is that going to be? That is going to be 5 is to 1. If 5 is to 1 turns out is the answer. And this is the correct answer. Irrespective of what other places on YouTube or Google might say. 1 is to 5 is the correct answer. Okay. All right. I hope you guys follow that. Now, similarly, I have one more equation, one more interesting problem for you. So in the diagram shown, a heavy cylinder of radius r is resting on two smooth surfaces, separating two liquids of densities 2 rho and 3 rho. The height h for the equilibrium of the cylinder must be yes, 2 classes per week. Because so right now because the JEE is almost here. So what I'm doing is 2 classes for 11th per week, 2 classes for 12th, and 3 classes for revision for JEE aspirants, revision of 2021. That is my schedule for the entire week. Okay. So 2 classes for class 11th, 2 classes for class 12th, and then I have 3 classes for revision of revision for 2021 aspirants. Okay. That is my entire schedule, if you must know. So this happens from Monday and Wednesday. This happens on Tuesdays and Thursdays. This happens on Friday, Saturday, Sunday. So I'm taking classes 7 days a week. Okay, all 7 days from 4 to 5:30. That's my fixed timing. Okay, you will find me here on this channel. Okay. Now this is another very interesting problem, and I would like you guys to give it a try first. So I'll leave you guys with this problem for homework. Okay, so try this. We'll discuss the solution of this in the next class. So this is your homework problem. All right. Now with that, again, there is equilibrium of flotation, which we will talk about in the next class. I will wrap up today's class because we have almost run out of time for today. Okay, so before I wrap up today's session, let me remind you, for those of you who are still thinking about getting that plus subscription and still haven't gotten it, this is how you can get it. So all you need to do is go to the plus section of the Unacademy app, select your goal as an ITJ and click on that get subscription button. Okay, that is how easy it is to get yourselves the subscription. When you follow those steps, you will be redirected to the payment page where you will find a box here. That box will say, do you have a code? So now you do, you have this code, which is RD Live. So you can use this code, and this code will give you a 10% off on all your subscription fees. All right. And now you can select from two of the subscriptions. Okay, you think it is option 4. Still. Let's try. Let's discuss it in the next class. You can take a screenshot, go back in the video. Okay, go back in the video and try this. Okay, and we will discuss this in the next class. And I think you might be right, by the way. All right, so now you can also choose from two kinds of subscriptions, plus and iconic. And when you click on proceed to pay, you can also select a lot of no cost EMI options for yourself. Okay, to break that payment also. You don't have to make that payment in one go. You can break it into a lot of easy no cost EMI options where your burden will be definitely reduced. Now, those of you who don't know what the iconic subscription is, here is what it is. Here is what this is all about. So this subscription will take your ITJ preparation to the next level. How it will be allotting personal coaches to you. So from our team of experts, you'll be allotted personal coaches who will closely guide you and mentor you throughout your IT journey. And you will also be a part of regular ITJ workshops. You will also receive expert guidelines from our experts. Now, you will also get a study planner, which is very, very important. And of course, you will have regular test analysis sessions, again, very, very important. So, with all these benefits and all your plus benefits, this will definitely take your ITJ subscription to the next level. Now, you can also go for a combo subscription if you are in class 11th. Okay, if you're coming to class 11 now and if you're worried, if you're looking for a single one-stop solution for all your preparation worries, then you can go for a combo subscription which offers you preparation for your ITJ and also your CBSE 11th and 12th. So there are 4 combos that are available. So these are the 4 combos. So first combo offers you the iconic subscription for ITJ and plus subscription for CBSE. The subscription starts at around 4,600 a month. Then the second combo subscription offers you iconic subscription for all 3, and this costs you around 5,500 a month. Then you have another combo which offers you the plus subscription of all these 3. This starts at around 3,000. And finally, you have a combo. Okay, don't undo. Okay. Finally, you have a combo which offers plus subscription for ITJ and iconic subscription for 11th and 12th. And this subscription starts at around 3,900 a month. Okay. Same to you, Nandu. Okay. Now, you can also take part in the next Unacademy JEE Combat. That's a great chance for you to test your knowledge. Okay, judge your standing amongst your peers, how you're doing with respect to your competition. And if you do well, then you can also win yourself some really cool rewards and prizes. Okay, so make sure you're taking part in the next Unacademy JEE combat event, which is going to happen live on the 17th of Jan. You can enroll now using the code RDLIFE and do well and win yourself some really cool prizes. Those of you who are following us on the JEE English channel of YouTube, don't forget to connect with us on the Telegram app using that link. So that will make sure that you are getting all the notifications of all the amazing sessions and lectures happening here on this channel, okay? So that you're not missing out on any of this amazing free quality content, okay? Again, okay, so there should be one more slide. So if you liked today's video, let me tell you about that. And don't forget to press the like button, okay, and share it with almost as many people as you can. Okay, so This is free quality content being given, provided to you by Unacademy. Okay, so make sure you're spreading it to as many people as can benefit from this. Okay, so like and share the video, and also if you're new to the channel, don't forget to subscribe. Okay, and that's it. Do remember to check out the important links given in the description box below. There are some really very important links for you that you can check out. So those will give you information of all the things that will benefit you. Okay. Now with that, let's finish and wrap up today's session. Now before I leave you, let me remind you one final time. This is my code RD Live. So if you like my lectures, if you like to enroll in my courses on the Unacademy Plus app, then this is what you can do. You can get yourself the Unacademy subscription using this code RD Live. It will give you a 10% off on all your subscription. With that, again, let's come to let's wrap up today's discussion. Next session of fluid dynamics will happen on Monday. So till then, you guys go through this session. Make sure that you understand everything that we talked about today, and make sure there are no confusions. And we will take forward this discussion on Monday onwards. Okay. Till then, you guys keep studying hard, keep practicing hard, and take good care of yourselves. Bye bye.